Okay, Bismillah. Okay, folks, welcome back. We're still looking at transformation of functions. Trick 167, grade A star question. Maths CD topic. Now, here what we're drawing here on the scale is the cos function y is equal to cos of x. Okay, from 0 to 360. Now, what we're going to do, we're going to modify this function by applying a big fat minus at the front. Put nice and big there so you can see it clearly at the back of the room. See on the video. Okay? Now, what is the effect of putting a minus at the beginning of the function? Not inside the function, but outside. Where we had the multiplier, put a minus there. What do you think the minus does? The minus acts as makes the work reflect. So your function that's above becomes below, and the one that's below becomes above. So we're literally going to reflect the function in the x-axis. That's what the sign is to do. So let's reflect now. Let's go at the main points. So at 0, cos of 0 is equal to 1. Now you reflect it from 1, it has to come down to minus 1. Cos of 90 was 0. We can't reflect, that's already on the x-axis, so it stays there. Okay, Zishan, the 0 point stays there, doesn't move, because it's actually on the middle line. That's the middle line. That point, Zishan, is on from here down to here. This point in the bottom, it was at minus 1, it now goes to plus 1. It goes up. This point is originally at 0 on the middle line, it stays on the middle line. Okay, now, cos of 360 is 1, we're going to reflect it in the x-axis, that point there, 1 becomes minus 1. So let's try drawing the function now again. There we go. So the original function Umar is given in blue, and our reflected function is given in black. Okay, so the reflected function is y is equal to, so put the red in there, and put the red nice and big. There you go. Minus cos x is the black one. Okay, has everybody got that one down? Okay, I'm going to quickly now flick through the sine one, and we'll try the sine one now. Okay, everybody got that one? Just quickly flick through. Okay, right. What we have here, we have a sine function, y is equal to sine of x. Ramiz, can you see, is this part also in the video? This part here? Yeah, can you see me? The part also in? Yeah? Done? Okay. Yeah, can you see that? Alright, now, y is equal to sine of x was our original function. Now what we're going to do, we're going to do y is equal to minus sine of x. So where we had our original multiplier, we got a minus here as well now. Minus outside the function, and the front where the multiplier was. That minus has the same effect to the sine function. What does it do? It reflects the function in the x-axis. The x-axis is the mirror line. So everything that is above becomes below, and everything which is below goes above. So let's do that now. Do it in red. So a 0 point on the mirror line stays on the mirror line. Okay? The 0 point on the mirror line stays on the mirror line. The 0 point on the mirror line stays on the mirror line. Because it's already on the mirror line, you can't reflect up or down, it stays there. Now, okay, Ifra, the sine of 90 was 1. That point has to be reflected from 1 down to? Minus 1, which is here. Okay, now, Ramiz, sine of 270 was minus 1.
Yeah.
Now we can reflect this point from the bottom to the top, and it's going to go to?
Plus 1.
Plus 1. Okay, now let's try doing that now. Okay, now let's label it. Okay, folks, are you with me today in the lesson? We're happy with this? y is equal to minus sine of x. So it's reflected it. Okay, that's a quick question now. If I was to take the minus half from there and put it inside the function, what do you think would happen then? If I put the minus inside the function, so the minus went from here to there, or into another function that we had drawn on there. What does it do? It doesn't reflect it in the x-axis, it reflects in the y-axis. Okay? So if the minus wasn't there, it was here instead, and you had a different function, you would get the function from this side and reflect it into the y-axis instead. So inside there is reflection in the y-axis, outside reflection in the x-axis. Okay, are we happy?